Hello, this is Mr. Wyrick. I'm here to talk to you today about lesson 10.4, Inscribed Angles. This one goes back to what we first learned about arcs and adds a little bit more information to that. So when we're talking about an inscribed angle, we're talking about an angle that has a vertex on the circle and is formed by chords of that same circle. There are three different cases. Case one is where it goes through the center of the circle. Case two, which is going to be more common that you'll see today, is where the center of the circle is inside that angle. And then case three, where the center is outside of that angle. Now what I have circled here on each one of these is what's referred to in the vocabulary as an intercepted arc, which is formed by that inscribed angle. So make sure you're taking this stuff down in the notes. Make sure you understand this is my inscribed angle over here. This is my intercepted arc. Regardless of the case, these same kind of theorems that we're looking at today are going to apply to all of them. On theorem 10.6, the angle measure for each inscribed angle is equal to 1/2 of the arc, or the arc is equal to 2 times the angle measure. What we are used to, what we have seen so far, is we have this central angle of 90 degrees, which would make this arc 90 degrees. If we were to take that center, that vertex of that angle, and not change these two endpoints, but stretch that all the way back here to being on the circle, making it an inscribed angle, we would have a 45-degree angle that would still make an arc length of 90. This would be 1/4 of the circle. So when we're calculating this, because they'll have you calculate this a lot, just make sure you understand which way it goes. If I'm back here and it's 45 on this inscribed angle, it's going to be 90 for the arc length. If they give me an arc length of, we'll make it a different number, say 110, then back there at that inscribed angle, it's going to be 55. So you can really see the larger this is, the more of that circle it's going to take up. On 10.7, another kind of thing here about arcs that we're talking about. If we have two inscribed angles that intercept at the same points, they have congruent angles. So two inscribed angles that have the same points have the same angle. I've kind of combined this picture for 10.7 and 10.8, so you can kind of look at what they've done back on page, if I were looking at it properly. If we're looking on page 724, 725, you can kind of see what they're talking about here, but I combine the two. If I have these 2 points here, then whether my angle is formed at this one or my angle is formed here at this one, it's going to be exactly the same angle because this arc length has not changed. So no matter where I place that angle within that, no matter how I try to draw it differently, it's always going to be the same degree angle on that, just because this is what my arc opens up to. On 10.8, again, I combined here with one picture. If the inscribed angle intercepts the diameter, then it is 90 degrees. So if I have 180 degrees here, for that semicircle, I've cut it in half, I have a diameter, then this inscribed angle here, or this inscribed angle over here, or wherever I try to put it, it's always going to be a 90-degree angle. Okay, so it's going to be one of those awesome right triangles down in there because it's intercepting the diameter, which really goes back down here. Okay. The arc is double the angle measure. So if I have a semicircle that's 180 on my arc length, half of that is going to be 90. So as long as I have that semicircle drawn correctly, if I have a true circle, no matter where I go trying to put it together, it's going to make it the diameter. Okay, and then 10.9, if a quadrilateral is inscribed, the opposite angles are going to be supplementary. So this one kind of, again, goes back to over here where I'm talking about double. If this diagonal here were actually to go straight through the middle, then this side would have a 90-degree angle, this side would have a 90-degree angle. If I can make it to where this one comes inside here, then this is containing more than 180. So if it had like 190 of the circle coming around at these 2 points, 190 divided by 2 would give us 95-degree angle for here. But that means that the rest of the circle, the rest of that 360 less the 190, is going to be 170. So I'm talking 85 over on this side. 95 and 85 still come together to make 180. Most of what you're doing with inscribed angles can really be summed up over here on 10.6. The arc length is double the angle measure. The angle measure is half of the arc length. If you can have a good understanding of that, you don't have to do much remembering of these specific instances over here on this side, the 7, the 8, the 9. The numbers that we will do for today's are 11 through 41 and 48. If you want to get a jump start on that, you can. But of course, I'll give you time to work on that during class. If you have questions about this, you don't really understand what's going on here, make sure to come into tutorials or ask me questions during class, and we'll see you then.